Hi, today I'm going to be teaching AS Physical Chemistry. I'm doing the AQA specification, and today I'm doing bonding. I'm doing 3.3, which is metallic bonding. So, metallic bonding, as you know, is the bond between two metal atoms. And the structure of this is a giant lattice structure, and it's made up of positively charged metal ions, or metal cations, and then the rest is a sea of delocalized electrons, which means they move freely between the cations. And how this is made is the outer shell of electrons on the metal atoms leave to become delocalized, resulting in positively charged metal cations. So that is how the metal becomes positive ions. Then the rest is these free electrons that came off of the outer electrons of these metal atoms. And so metallic bonding, what it is the electrostatic attractions between metal cations and negatively charged delocalized electrons. And these are very strong and they hold metals in their lattice structure. Okay, so there are three factors which basically determine the strength of the metallic bond. And so the first one is the number of delocalized electrons. So the higher number of delocalized electrons per atom tend to form stronger metallic bonds. This is because the increased number of delocalized electrons allows for stronger attraction between the electrons and the metal cations. So this means that more negative can bond with more positive, basically. And the next one is the charge of the metal cation. So a higher cation charge results in stronger electrostatic attractions between the cation and the delocalized electrons. So for example, let's take magnesium, because that's a metal, and it forms a 2+ ion. So that means that it'd be stronger than sodium, Na, which is in group 1, so it forms a 1+ ion. And the final one is the radius of the metal cation. So smaller metal cations have a higher charge density, which allows them to hold delocalized electrons closer to the nucleus. That's because they're smaller, and that means the electrons are in general closer to the nucleus, and that attraction is less shielded, less blocked, and can be pulled in more. Okay, and the last thing you need to know is the properties of these metals in the metallic bond, both through the bond and because of the giant lattice structure. And the first one is the high melting and boiling point. And that's because the electrostatic attraction in the lattice structure needs to be broken to break the lattice. And as we know, these are very strong. The next one is a good conductor of electricity and heat. This is because electrons can flow freely through the lattice, and this means that they can transfer charge, heat, energy by passing through. Okay, so the last thing you need to know is the properties of metallic bonds. This is both through the bond and through the giant lattice structure. And the first one is a high melting and boiling point. And this is because the electrostatic attraction basically needs to be broken to then break the lattice. And we know this electrostatic attraction is very strong, and so it takes a high amount of energy to overcome it. The next one is a good conductor of electricity and heat. And that is because, like I said before, it's metal cations bonded with a delocalized sea of electrons. And this means that the electrons can flow freely through the structure, and that means they can transfer charge and heat energy. Third one is that they are malleable and ductile, and this is because layers of the cation lattice can slide over one another when the metal is hammered or pulled, because there are no bonds locking the individual cations together. And the final one is insoluble, which means that the strength of the metallic bond prevents water or other solvent molecules from pulling the cations away from the structure and dissolving the metal. So unlike ionic bonding, for example, it's not soluble. And that is all you have to know for metallic bonding. Thank you. Have a nice day.